Professional course in English. Process technology. Equipment and systems. Unit 8. Instruments. In this lecture you will learn basic instruments, temperature measurement, pressure measurement, fluid flow measurement, level measurement, basic elements of a control loop. Automatic control is the foundation for efficient continuous flow processes. At one time, operators controlled processes manually. This type of process was valve-intensive. It required the technician to open and close valves in piping lineups manually. Modern advances in instrumentation have made it possible for industrial manufacturers to automate their processes. To a process operator, this means that an instrument or computer can control the opening, closing, and positioning of valves, start and stop equipment, measure process variables, respond automatically. This automation enables a single process technician to monitor and control large, complex process networks from a single control center. Basic instruments: gauges, transmitters, controllers, transducers, primary elements and sensors, computers, control valves, and other final control elements. Temperature measurement. Process technicians are required to closely monitor the temperatures of process streams. When heat energy is applied to an area, molecular activity increases, and energy is transferred from molecule to molecule. As this process occurs, pressure and temperature increase in an enclosed environment, materials expand, and density changes. Temperature is defined as the degree of hotness or coldness of an object or environment. Two commonly used scales are Fahrenheit, Celsius. The most common temperature measuring devices used in the chemical processing industry are thermoelectric. Thermoelectric temperature measuring devices come in two types: resistive temperature detectors (RTDs), thermocouples. Both RTDs and thermocouples are held in a thermowell, a chamber installed in vessels or piping. An RTD is a thermoelectric temperature measuring device composed of a small platinum or nickel wire encased in a rugged metal tube. The electrical resistance in the wire is influenced by changes in temperature. Temperature changes in an RTD are sensed by an electronic circuit and directed to a temperature indicator. Thermocouples are composed of two different types of metal. A thermocouple is designed to convert heat into electricity. When heat is applied to the connected ends of a thermocouple, a low-level current is generated. The higher the temperature, the greater the current generated. Electric current is detected easily by the associated electronic circuit and is converted to a corresponding temperature scale. Pressure measurement. Pressure is an important variable that must be carefully monitored and controlled in an industrial environment. Pressure is often defined as force per unit area, that is, the amount of force exerted by fluid on the equipment in which it is contained. Pressure is measured in pounds per square inch in the English system, kilograms per square meter in the metric system, newtons per square meter, or pascals in the system of international units. Two of the most common types of pressure are atmospheric, hydrostatic. Atmospheric pressure is the force exerted on the Earth by the weight of the gases that surround it. Hydrostatic pressure is the pressure exerted on a contained liquid and is determined by the depth of the liquid. There are three commonly used pressure scales in the manufacturing environment: gauge, absolute, vacuum. The most commonly used pressure scale is the gauge scale, on which values are expressed in pounds per square inch gauge. The gauge scale starts with atmospheric pressure, 14.7 psi, as 0 and moves up the pressure scale. The absolute pressure scale starts with a perfect vacuum as 0. Values are expressed in pounds per square inch absolute. The absolute scale takes into account atmospheric pressure. Vacuum gauges are designed to operate at less than atmospheric pressure. Vacuum gauges express pressure in inches of mercury. Vacuum is considered to be anything below atmospheric pressure. A manometer is a device that can be used to measure pressure or vacuum. It operates under the hydrostatic pressure principle that a column of water of a given volume always exerts a specific force. The liquid level of the water indicates the pressure. There are three basic types of manometer. U-tube manometer measures pressure in units of inches of water. On a well manometer, read the scale directly. The scale of an inclined manometer is also read directly, but the scale is expanded to make it easier to read small changes. Fluid flow measurement. Fluids flow through a series of pipes, valves, pumps, and vessels. Knowing and controlling the flow rate of a particular process stream are critical to the operation of the unit. Continuous chemical reactions require precise measurements to ensure that all of the reactants, raw materials, are combined in the proper proportions to form the final products. Feed rates and product rates must be accurately controlled for economic reasons. Process flow measurements can be taken by any kind of flow meter, but flow control most often requires a flow transmitter. Certain types of flow meters, such as orifice plate meters and Venturi meters, use differential pressure to measure flow rate. Fluid flow through a pipe can be related to pressure differences inside the pipe when flow restrictive devices, such as orifice plates, Venturi tubes, or flow nozzles, are installed. When the fluid flow encounters a restriction in a pipe, the pressure increases in front of the restriction. Fluid velocity through the restriction increases. The pressure on the other side of the restriction drops. Flow meters. Positive displacement meters, nutating disc and oval gear. Rotameter. Turbine flow meter. Magnetic flow meters. Ultrasonic flow meters. Vortex flow meters. Thermal flow meters. The Coriolis meter. In these figures you can see a rotameter and a turbine flow meter. Level measurement. Process technicians use fixed reference points, typically vessel taps, on which to base level measurements. The lowermost tap represents 0 level, and the uppermost tap is 100%. Correct level readings and control help make modern processing possible and profitable. Level measurements can be continuous, levels monitored continuously. Single point. In single-point measurements, readings are taken from a single point or from multiple points on a vessel. Single-point measurements are used to turn on or turn off the equipment, valves, pumps, compressors, motors, alarms, and to detect high and low process levels. Level measurement devices can also be classified. Direct, indirect. Direct level measurement instruments. Direct instrumentation is in physical contact with the surface of the fluid. Direct level measurement equipment may calculate the product surface level from a specific point of reference. Direct instruments include sight glasses, floats, displacers, probes. A sight glass is a transparent tube with graduated markings, a gauge mounted on the side of a tank. In a float and tape device, a float rests on the surface of the fluid, and the tape moves up and down, depending on the level. Displacers are buoyancy devices, or weights, that can be linked to a transmitter to control flow. Conductivity probes are high and low-level alarms. They use electricity to complete the lower leg circuit. If liquid reaches the higher leg, the circuit is broken. This type of system, which is designed to keep the level between the high and low conductivity probes, typically is used for non-flammable material. Capacitance probes are radiation devices or load cells. In these figures you can see a sight glass and level control by a displacer. Indirect level measurement. Indirect instrumentation incorporates pressure changes that respond proportionally to level changes. Differential pressure cells convert pressure differences to a level indication. They measure the hydrostatic pressure difference between 2 points on a pressurized vessel. Basic elements of a control loop. The key component of automatic control is the control loop, the group of instruments that work together to control a process. Process plants contain many control loops that are used to maintain pressure, temperature, flow, level, and composition. The basic elements of a control loop are measurement device, primary elements and sensors. Transmitter, a device designed to convert a measurement into a signal. This signal will be transmitted to another instrument. Controller, a device designed to compare a signal with a set point and transmit a signal to a final control element. Transducer, a device designed to convert an air signal to an electric signal to a pneumatic signal. Final control element, that part of a control loop, for example, control valve, damper, or governor for speed control, that actually makes the change to the process. The final control element is governed by a controller. To revise the learned material, answer the questions. What is the difference between manual and automatic control? What are the basic types of instruments found in the chemical processing industry? Describe a thermocouple and explain how it is used. What is atmospheric pressure? What is hydrostatic pressure? What pressure scales are used in the manufacturing environment? What is a manometer used for? What is a rotameter used for? What instruments are used for level measurement? What are the basic elements of a control loop?